Hey everyone, welcome back. In my game that I'm currently working on, I'm trying to use some pretty cool, I think, shader effects to get a reflection and some water distortion, as well as some of the distorted effects when the player goes through any of the gates that they can pass through in the game. And I thought it would be a cool idea to show you how I managed to come up with some of these effects. And I guess they're not mine, they're pretty common, but it took me a while to figure out how to actually do them, so I wanted to explain my process and some of the concepts behind getting these distortion effects to look the way that you do. So let's take a look at how to create some water distortion. And in the second part of this tutorial series, I'll actually apply this effect to a sort of body of water in an isometric game and show you how to create the reflections as well. So let's go ahead and get started. All right, so I have a couple of textures that I pulled off of Google, just some pool tiles that I thought it would be cool to distort. And we're going to do a couple of different things, and it'll make sense the further we go. But in the first version, the shader will apply to a color rect that will distort anything behind the color rect. And in the second version, the shader will apply only to the texture itself. And like I said, that'll make sense the further we go. But let's go ahead and start with our first one. So I want to add my color rect and then resize it so that it covers the texture I want to distort. So once we're finished, you'll see you can drag this color rect around and it will distort anything that's behind it. So I'm going to call this, let's call it screen distort. And then within that color rect, I'm going to go to material, new shader material, open that up, go to new shader, open that up, and I can start actually editing my shader code. And because it's a shader, the very first thing you want to do is define the type. That's probably the error you're going to get whenever you first open up a new shader. So we're going to call this shader type canvas item. And canvas item applies to any 2D effects. So because we're editing, or rather we're going to be affecting the colors that are within this texture or within this shape, as opposed to the edges or the corners or the vertexes of this shape, we're going to be using the fragment function. So the next thing I want to write is void fragment, and then open up curly brackets. And that is the beginning of pretty much any shader, depending on whether you're using fragment or vertex, etc. But you always want to define the type and then open up that function. So the very first thing we can do, just so we can actually see something behind the color rect, is affect the color rect's colors so that it copies what's behind it. And to do that, we're going to use the screen texture and the screen UV. So we're going to type color equals texture, and the texture function reads a texture. And just like I mentioned, we're going to read the screen texture and the screen UV. And as soon as we do that, you can see that the color rect now is basically copying anything that's behind it. So you can't really tell there's a difference. But we're going to distort what that color rect is copying, and then you'll be able to see how it's sort of copying and then changing the colors that are directly behind it. So distorting what is on the screen is actually kind of easy in terms of what you need to do. It's just weird to think about how UVs actually work within shaders. So for example, screen UV is a vec2. So I can just add another vec2 directly to the screen UV, and it will actually distort the screen. Not exactly how we want it to currently, but you can at least see something happening. And then if I drag that color rect around, you can kind of see that it technically is distorted, but it's kind of weird. It's certainly not changing over time or anything like that. But that is essentially what you need to do to distort the screen. All you have to do is affect the UVs of the screen texture or the texture itself in some way in order to achieve some sort of distortion. So I'm going to comment or delete that out for now because we're going to apply a bit more of a fancy distortion. And to do that, we're going to use something called a noise texture. Now, there's a couple of ways you can get your noise texture. Godot allows you to generate a noise texture directly within the shader code. You can also make a static noise texture within a sort of photo editing program like Gimp, and I'll show you how to do that at the end. And generally, if you're in a game and you want to have some sort of distortion effect, I recommend using a static texture like one you make with Gimp, because it uses kind of less resources to create. And you're not constantly telling the computer to like do a bunch of math to create the noise texture itself. But having said that, for now, just for sake of simplicity within this tutorial, we're going to go ahead and create a noise texture manually. So to do that, I'm going to go or type uniform sampler 2D, and we'll just call it noise. So then I click back on my colorect and go down to my shader parameters. You can see now we have a noise parameter, and we're going to open that up and then go to new noise texture. Click on new noise texture and open that up. And you can leave pretty much everything the same, except you want to click on seamless, because that makes that noise texture tileable. Basically, when you scroll it, it will look the same regardless of the direction you're scrolling it. And then under noise, I'm going to open that up and click on new open simplex noise, and then click on that. And then actually, for now, we can leave everything as its default, as long as there's that new open simplex noise there. As soon as we click on that, we can go back to our shader and start using the values that are from our noise texture. If we click back on our colorect, you can see that actually it updated, and it gives you a preview of what that noise looks like. And all it is a black and white image with variation between different parts of the image and whether different parts of that image are black or white. As far as the shader is concerned, when we're sampling this texture, the black parts of that noise texture are going to be closer, well, 0 or close to 0, and the white or closer to white parts of that picture are going to be 1 or closer to 1. And all we're doing is getting a value between 0 and 1 from that noise texture and then adding it to the screen UV, essentially. So let's go ahead and sample our noise texture. And I only want one value between 0 and 1. So this is going to be a float, and we'll call it, let's say, noise value. And we're going to read from the noise texture. So this time I'm going to say noise in UV. Now, should give us there we go, should give us an error because the texture read is by default a vec4, and we have defined this as a float. So all we want to do is take basically one channel of this data and use that for our float value. So if you think of color data in a computer, it's RGB and then an alpha channel, so RGBA. That is vec4 data within the context of a shader. So we only want one of those channels, and that will be one value between 0 and 1. So we can use that for our float. So we're just going to go ahead and only use one of those channels. So now we have a float value that we can use to distort our noise texture. So let's go ahead and add our noise value to the screen UV. But because the screen UV is a vec2, we want to make sure that to use this noise value in a vec2. So we're going to say plus vec2, and we'll say noise value. And you can see you've already got some distortion. Good job. We're not finished. So it kind of is that simple in terms of the amount of code you have to do, but we're going to do a little bit more to get it to look like how we want it to. So currently the effect is static, so it's not moving, and we want it to move. So that means we're going to involve time. So let's go ahead and add our time built in to our UV. And you can see it definitely is not doing exactly what we want, but it is moving. So this is pretty much the full effect. Now we're going to add some uniforms that actually get it to make it look like exactly how we want it. But time plus the UV and some value added to that UV is how you get distortion. And we're sampling a noise texture to get that value. And remember that value is just one channel of the total RGBA vec4 that we can read that noise texture to get. So let's add a couple of uniforms here, just some variables to get this to look a bit more like we want it. So let's add a uniform float speed, and we'll say time times speed, and that way we can sort of control the speed of this. So speed is currently 0, which is why it just stopped, but let's give this a hint range. I don't want it to be 0 because I always do want it to be moving, so we'll say the lower end of that is 0.05, and then we'll just say, let's say 0.5. And we'll set a default value at 0.1, let's say. So now our default value for the speed is 0.1, and so it's slowed down. So if we click on our color rect over here and go back to our shader parameters, we can see the speed, and we can slide it up and down. And if we go 0.5, it's faster, all the way down to 0.05, much slower. So there we go. So another thing we want to do is try to center this effect. So this is a little bit weird, and it involves some math that I'm not quite sure I understand, but I just remember how to do it. Basically, when we're distorting the image, all we're doing is moving it in a certain direction. So in order to center the effect, because you can kind of see there's a lot of empty looking space up here in our pool tiles or down at the bottom left corner, to center the effect, we're basically just moving it back against the direction it was distorted in a little bit. And the first thing I want to do in order to do that is actually give us a value we can use to mess with. So I'm going to add another uniform and call it strength. And this will actually be the strength of our distortion effect. Just got to spell that right, and actually add the uniform. So say uniform, and this will be another float, say strength, and we can actually copy everything from our speed uniform up here. There we go. And you can already see that it kind of did what we wanted. It basically is recentering the image a little bit, and it's not quite there. For example, if I go back to my color rect and I increase the strength, you can see as the strength goes up, it pushes it off to the side. What we want to do is correct that. So in our screen UV, I want to subtract the strength divided by 2. And I like to put it in parentheses just so it makes sense within the line. But that centers the effect. So you can see now we got some nice water distortion going. If I increase the strength, it increases the distortion without pushing it off of the color rect itself. So there we go. You've just created a water distortion shader using a value from our noise texture by affecting the screen UVs and adding whatever sort of strength and speed modifier uniforms that you want. And you've centered the effect by making sure to subtract that same strength modifier divided by 2. So that is pretty much as simple as cool looking shaders get. So for example, or like I mentioned before, if you move this around, you can see it affects everything that's behind it. So you can apply this effect to any color rect, and anything behind it, you will see this distortion on. So that's our first shader. Let's move on to the second one, which is applying the same effect, but not to a color rect on top of something. We're going to apply it to the texture itself. Instead of apply this to a color rect that affects everything behind the color rect, let's apply this effect to a texture itself. And you can see there's a little bit of a difference in terms of how it shows up, but the actual shader code is pretty much the same. So we've done most of the work. So I'm going to go back to my color rect shader, go into my shader code, and actually just copy all that stuff. Then, for the texture that I want to apply this effect to, I'm going to go into Material, New Shader Material, add a new shader and just copy and paste everything from my other shader. I'm going to save that, and nothing's happening at the moment, but so in that texture that we just applied that shader to, I'm going to go into my shader parameters, and just like previously, I'm going to add a new noise texture. Open that up, make sure that seamless is checked, and under noise, new open simplex noise. I can click on that to open it up, and I'm going to leave all of that as default. So I'm going to close that, and you can see the texture right there. Open up my shader again. Previously, our effect was applied to the color rect and everything behind it, and we were using the screen texture and the screen UV, but now it's the texture itself. So all we have to do is remove the screen part of the texture and UV built-ins here, and it will affect the texture itself. And that's it. Everything else is the same. We're still using a noise texture, getting a value from that noise texture, and then affecting the UVs of the texture that we've now applied the shader to itself. So I click back on my texture over here, click on my shader parameters, I can affect the strength of that effect just like we did with the previous one. And you can kind of see how it's a little bit different depending on whether you apply it to a color rect and then whatever's on the screen behind that color rect versus the texture itself. But that's how you do it. It's relatively simple. It just kind of is weird to think about how the UVs and how getting the values and stuff like that works if you're first starting out with shaders. But you can apply that to all different kinds of things, whatever you want to distort. All right, so I mentioned that it might be a good idea to use static noise textures instead of generating them in real time in Godot in your shaders every time you need noise. So I'm going to show you how I use Gimp to create noise textures for my game. And it's pretty simple. I'm going to go to File, New, and I like 512 by 512 since that's the sort of default size of any textures that you create within Godot. But any texture you need is fine. Doesn't really have to be that big because we're just getting a value from that texture anyway. So I'm going to click OK. And then it doesn't matter what color your background is because the filter we're going to apply is going to pretty much erase all that. So under filter, we're going to go to render, noise, and solid noise. So solid noise looks pretty much exactly like the noise you would generate in real time if you used open simplex noise within Godot. And the one thing you want to make sure you do is click tileable. And that means that your texture is seamless and can actually be scrolled without creating any hard lines or anything like that within the texture. And then once you do that, you can sort of change its size to be whatever you like. And I think I'll go with something like that. Click OK. And then one thing I like to do is actually change the contrast so that the darker areas are darker and the brighter areas are brighter. And it just creates a more defined effect, I feel like. So I'll go up to Tools, Brightness and Contrast, and then bump up the contrast a little bit. Doesn't have to be solid black or solid white or anything like that. Doesn't have to be too harsh, but as long as you get some more definition between the light and dark areas of the texture. And there we go. And then you can just export that as a PNG or a JPEG or whatever and use it in your game to sample instead of using a generated noise texture.